Okay, in today's lesson, our goal is to understand the following identities: the reciprocal identity, quotient identities, Pythagorean identities, odd-even identities, and cofunction identities. And we also want to be able to use these identities to simplify some expressions. So first, let's look at our reciprocal identities. So these we've already seen before. Our reciprocal identity of sine is going to be 1 over cosecant. So the reciprocal identity is going to look like this. When we have cosine, cosine is the same as 1 over secant. Tangent is the same as 1 over cotangent. Cosecant is the same as 1 over sine. Secant is the same as 1 over cosine. And cotangent is the same as 1 over tangent. So again, these are ones we've seen and used before, and you need to have these memorized. And so there's going to be 6 of those. Then we can move on to our quotient identities, which again, we've also seen some already. So there's only 2 quotient identities. The quotient identity of tangent theta is sine theta over cosine theta. And then the quotient identity of cotangent is going to be the reciprocal of that. So cosine over sine. So note, you can also find this by taking the reciprocal of tangent and doing 1 over tangent is the same as cotangent. So they're just flipped. So these 2 we also have to memorize. Again, we've seen these before. So next, let's look at our Pythagorean identities. So these are going to be new. So our Pythagorean identities we can find by using our unit circle. So we know from our unit circle this is going to be a radius of 1. We know this point here is going to be cosine theta, sine theta. Okay, so that means this triangle here has a width of cosine theta and then a height of sine theta. Okay, so now we can create our Pythagorean identities by using this. We can use our triangle here to get one side squared plus the other side squared equals our hypotenuse squared. And this can simplify to cosine squared theta plus sine squared theta equals 1. Now, note, these 2 look a little bit different because of where the placement of the squared is, but they are equivalent. So this is just this way is the more standard form to see it, but this one is also correct. So we created this by using our unit circle and our Pythagorean theorem. So now we kind of want to see what our other Pythagorean identities are. So this is our first Pythagorean identity. Now, what happens if we take each of these and divide each term by cosine squared theta? So let's take a look at that. So we take cosine squared theta plus sine squared theta equals 1. Okay? And we're going to divide each term by cosine squared theta. And so cosine squared theta of cosine squared theta equals 1. Sine squared theta over cosine squared theta equals tangent squared theta. And then 1 over cosine squared theta is our reciprocal identity, which is going to be secant theta. Secant squared theta. So here, this is our second Pythagorean identity, and we can find our third one by taking our original and dividing by sine squared theta. So we have 1, and then we're going to divide each of them by cosine squared theta, or sine squared, my fault, sine squared theta. And here, cosine squared theta over sine squared theta is cotangent squared theta. Sine squared theta over sine squared theta is 1. 1 over sine squared theta is going to be cosecant theta. And here's our third identity. So now we want to kind of memorize these identities. If you ever get stuck, you can derive them, but it might be a good idea to memorize them. So let's look at what three of our three Pythagorean identities are. So our first one was here is our cosine squared theta plus sine squared theta equals 1. The second one we found by dividing by cosine squared theta. It's 1 plus tangent squared theta equals secant squared theta. And then our last one we found by dividing here by sine squared theta. And we get this following one. So again, we have to memorize these. Alright, so now let's look at our next group of identities. We have even odd identities. So sin x is symmetrical about the origin. So that means it's odd. Okay, so from here we can see that we're going to get, this is going to be similar to how we found our even odd before. We're going to have sine of negative x equals negative sine of x. This is like saying we had f of negative x equaled negative f of x to get an odd function. Very similar. So let's try cosine. Cosine is going to be symmetrical about the y-axis. And I meant to write that above before. So it's symmetrical about the y-axis, which means it's even. So cosine of negative x equals cosine of x. Okay. Now tangent is symmetrical about the origin. So tangent is going to be odd, which means tangent of negative x is equal to negative tangent of x. Now cosecant is symmetrical about the origin as well. So again, it's going to be odd. And you'll get the cosecant of negative x equals negative cosecant of x. Okay? Now secant is symmetrical about the y-axis. So we'll have this being even. So the secant of negative x equals the secant of x. And then for cotangent, cotangent is symmetrical about the origin. So it is odd. And that means cotangent of negative x equals negative cotangent of x. Okay? So for these, we're used to looking at the graph and seeing if it reflects over what and what. So when it reflected over the y-axis, we knew it was even. That's saying the same as it's symmetrical about the y-axis. Now, if you look at our odd functions, for example, sine was odd. To get it to match up, you had to reflect it over the y-axis and over the x-axis. That is the same as reflecting it over the origin. So that's how we know that these ones are even. So now these you want to know these properties over here. They're going to be very, very useful. So you're going to try and memorize these as well. Now, next, let's look at our cofunction identities. So our cofunction identities are coming from our unit circle again. We look at sine of 30, we know that's equal to 1/2, but we also know the cosine of 60 is 1/2. So these are cofunction identities because 30 degrees and 60 degrees are complements. They're complementary. 30 plus 60 equals 90. Alright, so we can use this to talk about a whole bunch of angles, and we can say that the sine of one angle is equal to the cosine of another angle. So in this case, the sine of angle A is equal to the cosine of angle B. And I can also switch. The cosine of angle A is equal to the sine of angle B. So here we just switched which angle we were taking the cosine over the sine of. This works for tangent and cotangent, and then here secant, cosecant can be switched as well. So these are going to be useful when we're looking at simplifying things. Okay. Going on with that, we have values of a function at A is the same as its cofunction at B. This always happens with complementary angles. Notice you have the co is the same. It's important to note that these are different than your reciprocal identities. Okay, so sine, in this case, sine is going with cosine. You take the sine of pi over 2, which is your 90, minus your angle. This is showing that they're complement. You'll get cosine. Similarly, cosine of the pi over 2 minus your angle is get sine. And it'll work for your other ones as well. So you got to remember that these are co-functions. And it's dealing with complementary angles. That is when they're equal. Now let's try some examples of simplifying. So let's look at this one. We have sine cubed of x equals sine of x times cosine squared. Here we can look and see if we can factor. So we can see that we can factor out a sine of x. So here we can say sine of x times sine squared of x plus, so we took the sine of x out of here, take the sine x out of here, cosine squared x. Now this is one of our trig identities, our Pythagorean identities, so we'll have the sine of x times 1, which is just equal to the sine of x. Okay, it's important to note that there's almost always various ways to go about these. So if it looks different than what your friend is doing, it's probably not wrong. There's various ways to go through these, so just make sure you know that. It's not one way to do all of them. You might find a different way to do it than I'm doing right now. So our second one is going to be secant of x plus 1 times secant of x minus 1 all over sine squared x. So let's distribute this here. So we'll have secant squared x, and these are the difference of some perfect squares. So secant squared x minus 1 over sine squared x. Now note here that this is one of our identities. This can come from 1 plus tangent squared x equals secant squared x. So if you subtract 1 from both sides, you can get tangent. You'll see that secant squared x minus the 1 is tangent squared x over sine squared x. From here, we can say, we don't use the arrow, we say equals. Tangent squared x is the same as sine squared x over cosine squared x. And we can break this down. We'll have sine squared x, all over sine squared x. We can break this down to sine squared x over cosine squared x. That's our top part. Times 1 over sine squared x. So I'm just multiplying by the denominator there. And our sine squared x can cancel out. We're left with 1 over cosine squared x, which is one of our reciprocal identities of secant squared x. So this is our answer. We can simplify this all the way down to secant squared x. Okay, so let's try another example. We have cosine of x all over 1 minus sine x minus sine x over cosine x. So here we can find a common denominator. So we're going to multiply top and bottom here by cosine of x. Put some parentheses there. And then we'll multiply this side by 1 minus sine x over 1 minus sine x. Okay, so now we're going to have cosine squared x on top over here minus distributing sine x plus sine squared x all over our common denominator of 1 minus sine x times cosine x. So we can rearrange a little bit to help us see this a little better. We'll have minus sine x, that's here, plus our cosine squared x plus our sine squared x all over our denominator of 1 minus sine x times cosine of x. Now notice this here is one of our Pythagorean identities. So we'll have minus sine x plus 1 all over 1 minus sine x times cosine x. And these are the same as 1 minus sine x, so these can cancel. We'll have 1 over cosine of x, which is our reciprocal identity, and we can get secant of x. That'll be your answer here. Alright, so we'll go through one last example. I want to factor. So here we have 1 minus 2 sine x plus sine squared x. So I'm going to let y equal sine of x. Okay, so I can replace all of my sine x's with y. So I have 1 minus 2y plus y squared. Rearrange y squared minus 2y plus 1. Okay, so this looks like something I can factor. I'll have y minus 1 and y minus 1, which is the same as y minus 1 squared. And our y was our sine x, so we can substitute that back in. We'll have sine x minus 1 squared. And this is simplified. Okay, so this is how we factored there. Okay. And then there's just some important things to remember. You must memorize all of these. So our 5 types of identities. We want to memorize them, okay? You're not going to have time to kind of derive all of them again. There's something you need to memorize. You need to know these, you need to know them quickly. There's often multiple ways to go about each problem, so don't worry if you're doing it a different way. You might be right. So try them. Try and solve them different ways. And it's important to remember there are 3 different types of functions. I know it can get confusing. We have our inverse functions, our reciprocal functions, and our cofunctions. They're all different. You got to make sure you know the difference between these. Okay? So that is going to be it for this lesson. Make sure that you wrote all of these down correctly, that you're memorizing them, using them. It might be helpful to make note cards. Give yourself little flashcards to help memorize these, okay? So make sure you're studying these, memorize them, and you'll be good to go.